going to classroom meet, then
So there's always a ton of questions in lab, and again, my way of doing things is not like normal people. Okay, so my brain isn't like normal people's brains. So if you ever saw Young Frankenstein, when Igor got my brain, Abby something, Abby normal, right? So I got the Abby normal brain, and I'm kind of like an ogre with hairy knuckles, and they put me together in a lab, and it just didn't work out the way other people did. So when I'm doing stuff, I don't really fit in with chemists or scientists either, because generally when you think of scientists, you think of quiet, careful, weighing everything before they say things. And if you're in my class, you're going to hear me make a lot of mistakes. And a lot of times people don't like to make mistakes made. They want to just hear the right thing the right time. But sometimes when you make a mistake, you can get something out of it. As a matter of fact, normally making mistakes is how you remember things. Right? You do it wrong, and then you get corrected, and then you remember. So one of the questions that we have, and one of the things I want to talk about here is, I don't give a lot of guidance when it comes to reports at the beginning, because I want you to use your brain to try to figure out what something means without being spoon-fed. It doesn't mean I'm going to hold you to where I expect you to be at the end. In the beginning, we're going to evolve from a bunch of primordial ooze into giant superhuman beings at the very end of our existence that are ethereal and that have come to great understandings about all the wonderful things. And then, like my mom, who's 89 years old, tells me, we were together in Atlantis. And I go, well, it's not science yet. Okay, but I believe you, Mom. Okay, and what a cute little old lady. All right, so we have our web page, and there are modules, right? And under modules, click. And if you don't believe me, we can do student view. Not the same on the phone. And I'm not quite sure why I'm having such trouble having a one platform canvas, but it really got to me this semester, because I had a great web page all set up, and I just couldn't get it to fly on the phone. So we have lectures, Chem manual. So there's your manual. It's zipped, right? Because I can't really give you the Chem manual and compete with the bookstore. It's zipped, whatever that means. I'll let you guys figure out what it means. It's zipped. I don't know. Apparently you could unzip them and do something with them. So here's some lab reports for you to check under the lab reports section. And that's my guidance, right? My guidance is, here's a report. And what do we got here? Let's blow it up a little bit. Okay, it's redacted. Redacted means blacked out. I just did this because I love when the government releases a report, and it's like the of 7, and you're like, what? What does it even mean? Okay. And so what are we looking at here? Can we read this at all?
Yeah, you zoomed in wrong.
I zoomed in wrong? Oh yeah, I used the computer zoom. Fool. I should have used the other zoom. There we go. And the zoom is
scroll up
there.
It's on the top right.
Here we go. I thought I could read it. Well, you can almost read it.
Full screen right next to zoom.
Correct. Okay. And you still can almost read it, right?
Kind of.
But you can see what's going on here. We've got, what is that first thing?
Purpose.
A purpose, right? So we're going to put a purpose into a sentence. What was the first lab we did? Was measurement, kind of lab A, right? We're going to find the volume. We're going to find the volume using a series of measurements would be a good purpose. We're going to explore density through the measurement of volume would be another way of saying it, right? Just one or two sentences. Now, this one has a theory. Ours didn't have a theory because we weren't doing a bunch of theoretical stuff. But in the more complicated experiments, we're going to have a purpose, why we're doing the experiment. That's all that is, why we're doing it. You put it in your own words. If I don't like those words, and you do it, I'm still going to give you full credit, and I'm going to tell you what I want you to do next time. Right? So don't worry about how many points you get. Do the lab, do the write-up to the best of your ability, and then I'll try to guide you or edit you into what I want. Until when I give you the notes, you're like, oh yeah, I should have done that. Right? I don't ever expect you to not get edited. Because why? What would be a reason why you could always get edited?
Class reporting.
Ooh, no.
You were
Yeah.
like
I don't think of that word.
master of it already, or no? Like,
No. Because someone always has an opinion on something.
Okay, that's okay.
There's always room for improvement.
There you go.
There we go.
Right? And just what I mean is, and by that isn't that I know what the best writing should ever be or how to but I do have a lot of experience with scene writing and getting people to where they can go to the next level and then succeed. Right? And that's what we're really trying to do. We're trying to take you from where you are. When they say you can go anywhere, you got to be prepared to go anywhere. You can't just go, yeah, here you go there. Because you go there and then you'll come home. You see a lot of students who think they're ready to move out and get sent to schools in the Ivy League because they can qualify. And then after the first semester, they're home. Why? Because they didn't grow up in that kind of environment. They didn't understand what it's like to live somewhere else with different weather. I'm not saying you can't do it. I'm saying it's a lot easier if you prepare to do it. And so if I'm saying, yeah, that's better, and then I change it back to what you had before, this is what happens when you do a doctorate. You submit your paper, your boss edits it, he changes it, you change it, you send it back, he changes it back, and you go, that's what I just said. He goes, I know, but we needed to explore that option, right? Maybe it sounded better. And then we went back to it. So part of being involved in writing and improvement is the communication about what sounds better, what fits better, how we can say the same thing more directly, or in some cases less directly, right? How can we lead someone? And this is all like little nuances. We don't need that. Right now we're just saying, hey, these are our first chemistry labs. We're going to write a paper and it needs to have a purpose. And that purpose is what we're doing. And if I like your purpose, I'm not going to do any correction. And then I may like that purpose, and so you go, oh, that's what he wants, and now I'm going to do it again for the next lab, and I'm going to make a suggestion. But it could be because I thought of something else to add, okay? So all that part, again, doesn't fit the model where here's 2-point rubric, here's... The rubric is at the end. Now we have clear definitions of what we're doing. The rubric isn't in the beginning, because in the beginning we don't have a definition of what's the best purpose. Can you guys live with that? Or do you need me to define that immediately in concrete and then grade you accordingly?
I can live with it.
The former. Let's figure it out ourselves and then, yeah.
Anyone not okay with not having the rubric in front of them? Okay, I see no hands for the camera. Okay, the next step is theory. So theory is where we discuss what's the reason behind our measurements. And when we're doing the density, and it's really not worthy, but when we're doing the next level, we're going to talk about what are the reasons we can think this experiment could work. What are the mathematical reasons? Okay, so we have purpose, then we have theory. We didn't have to have theory on the first one. Pretty much on the second one either, unless it asks for it, which you'll determine by reading. Then we have, what part is this? The procedure. Now, there are two methods of thought to this. My method is whatever it takes for you to write down the procedure and be able to do the experiment without looking at the procedure. So the steps are in your lab book, but you want to write it down so if you caught your lab book on fire, or the dog ate it, or you fell out of your car while you're driving down the freeway because you hate chemistry and you winged it, but then you said, shit, I need this class, and so I'm going to be here. You need to be able to do that procedure. Now, there are two ways of doing that. There's the split method, and then there's the one-line method. We are going to use the procedure and then data afterwards. We're not going to have procedure linked to data, even though I like that a lot. In this class, we're not going to do it that way because we're preparing you for what comes next. And I really want to feed that 151 class, get you as close to that as possible, because within the series, I don't want you to have to change your mindset, because dealing with me is enough and dealing with Danae is enough, and so I want to be on the same page with her, and as she makes changes, so will I. So we're going to have this, in this particular experiment, they put the steps, and then as they did the steps, they put the data next to it. I really like that. And anyway, but we're not doing that. Okay, so, but it is an accepted methodology. So then we're going to do data after that. So we're going to have purpose, which is what we're doing, theory, why we're doing it, procedure, right? And then our data and data tables. And the idea is to have these data tables ready to go for our data analysis. Okay? And then at the end, we're always going to have a conclusion. Now, this is a part that some people don't pay a lot of attention to, but I like it. And what do we do in a conclusion? We reiterate our data, our analysis, and what happened. So you would say, we measured several volumes using these different methods. Our average standard deviation was, this leads us to believe, based on the measurements, that the density is X. That type of statement. The supporting evidence based on our data analysis says, our confidence interval is, these are all things that we want to say. What we don't want to say in a lab ever is I, me, we, right? It's impersonal. Why? Because personal attachment to data leads to bias. So we want to appear that we have no bias whatsoever. Not real, but because we want our experiments to work and we want the data to match what we want it to be, even though we're kind of, well, we didn't really do that. But the whole idea is that you spend your time carefully crafting your sentences so that you take the we out. If you put we in, it's not a big deal. You just take it out and restate it. And if I see it, I'm going to point it out. That's all. Because we're not used to writing that way, most of us. Of course, people like me are very used to not writing that way. All right? And so you see the length of this. This isn't, here's some circles, but basically this is a 15 out of 15, 20 out of 20. Now, if you leave out any section, you're going to lose points, right? So put something in there, get the points, get the corrections. All right, what else we got? Let's look at another one. Oh, and then we're going to do homework. It isn't taking that long. It just feels like a long time because I've been talking already.
Right there.
All right. So there's one, and then let's look at one. Let's look at one of the ones that's not really that great, or maybe I think this one's not that great. Or maybe I only put the great ones up there. Yeah. So this one, what the heck, dude? You just got some data. This is not going to fly, right? You're going to get like 5 points. I mean, the data's good. It's a good, right? Oh wait, that's not one. Yes, it is.
You said it's good. Example good.
It's an example of good data, right? Not a good report, but good data. This is how you do data and how you write. That part's good. Sorry, Rose. Oh, I forgot why. Thank God it said good on it, because I was about to ding you terribly. Do we have a not good? Maybe this is not good. Maybe I didn't even put any not good on here.
I went through a lot of them. Most of them were all good.
Right. Well, I want you to see what the good examples are, right? Don't care.
It's dismissed.
All right. Last example. Hopefully this one will be. I think there's something missing on this one. Right? No,
18 out of 20.
yeah, and so there was something in here that wasn't liked. You got the stamps. I'm not so big on the stamps. I mean, you're here. I wanna see, so what are the stamps for me? And it's just initials for me. It's just to show me that you did something before you left. That's what it's for. So any questions on lab reports? What I'm looking for? Does that calm you down a little bit? Yeah.
So do you want us to put the procedures and the data on the same page? And if it fits, is that fine, or do you want?
So I want, yeah, you can put it up on the same page, but I don't want it,
Okay, so you want to,
I want it written out long ways, right? One section is procedure, the next section is collecting data.
okay.
Yeah,
Well, I found this
So for these first couple labs, there won't be a theory section?
right, because we're just doing a measurement, and that's okay. Yeah,
Do you want the pre-lab assignment in the report?
Yeah.
pre-lab, I want the pre-lab pictures taken and submitted to the pre-lab section of the report.
Yeah. So, like on mine, I put my pre-lab right under theory. So it's complete, but it's part of my overall.
Right, so you're gonna, however you set up
Take a
your,
picture of it and submit it.
take the picture of the pre-lab portion and submit it under the pre-lab section. The order of your book makes no difference to me, and yes, go ahead.
Do we need to like have your signature on the scan before we send it
No,
in? Okay.
if you do the pre-lab and you're done with it before you get here, and you submit it before you get here, that's great. That's what I prefer the most, right? Is that you don't wait for me to check it, you just put it in. All right, great questions. Anything else? All right, let's look at homework 1. Let's see if there's anything on there that we need to be concerned with. Oh yeah, lights are all in the same place. I'm looking for my water that I don't have. So.
That's right.
And again, if I don't hand you out homework 2, is homework 2 due?
No.
No. If I don't hand you out reading quiz 2, is it due?
Nope.
No. Okay. What's the other thing we do? In-class quizzes. Can you do an in-class quiz if I don't hand it out to you?
Nope.
No. Okay. So no more worries about that, right? If I haven't given it to you, it's not due. If you haven't been in class, now you got something to worry about. Who do you go to?
Other student.
Other students or me, right? I'll gladly tell you, no, I didn't hand that out, or yeah, I did, or but other students. And oh, did I put anything on the discussion board?
I didn't see a discussion.
Oh no, it's not on here. What the heck? Oops. No wonder you guys didn't see it. Attaboy. Oh, really, Jim? Okay.
Yeah, exactly. Had a question about the pre-lab, and I'm like, oh,
You can't put it on there because there's no discussion board available.
and
'cause
canceled office hour. No.
I didn't cancel off, so I actually was here. I actually got here
Oh,
earlier
really?
than I thought.
Oh, okay.
I couldn't find you again.
No, I was in, did you 2109?
So I came here and
Yeah.
what's his name?
Toby. I
Toby.
didn't come in here though.
I know, I came here
Right.
at 11:30 and then Toby said everything's back in the regular hours, so I went up there and I couldn't find you in there. And then I went next door and asked the lady and I couldn't find you in there.
Right.
And then I sent you an email,
Right, and then got the email and I was here in my office.
killing me.
There's no way.
I'm trying to come to every office hour you have.
I swear to God, I'll be at the next one.
Okay, I'm gonna find you.
What, the homework one? Yeah, I think I have one in my backpack. I'm sorry, Brittany.
It's okay, I just want you to know,
I know,
I
I
will
know.
find
So
you.
due Thursday, so I can send you.
Okay, everything's nice.
Yeah.
I'm pretty slippery.
Get hide from me.
I have a very specific set of skills. Set of skills that make me a pain to deal with.
What was your question?
I know there was like a second page
I will
to
find
put
it.
homework.
Right?
Oh yeah, so it's on Canvas.
I saw on Canvas there was a second page. I just never got it in person.
Isn't there a second page? Oh, it's this
All
right
right,
here.
so,
It's this
I actually don't have to.
Do you want to
print
take
out my
pictures?
Okay,
I
it's
don't
on
fix that
Canvas. I
discussion.
saw it on there. I just
Yeah.
wasn't sure.
That's
Yeah.
Part of it.
so.
There you
Our
go.
first question
That's on
on this.
Chem's
How come I didn't give you the whole thing?
Yeah, there's 2 pages.
Yeah, I only gave.
Oh.
Were you able to register? I understand that. But you better make sure you get on there before they lock everything down, because otherwise they can't say you're part of the class, and they'll think, why was she coming to class and she's not registered, and then I'll get in trouble, and if I get in trouble, I don't care. Because I'm always in trouble, because I don't do things the way everybody else does.
Valid.
And you get used to it, it's like a battle cry.
You'll never get in trouble. They'll never be able to find you.
You can only get yelled at if they
That's too
find
good.
you.
Okay. So, yeah, have fun at my expense. I appreciate it. I love it, as a matter of fact. I wouldn't know what to do if people weren't making fun of me. So, over being a science major. You know, if you ever want to know why you can't trust scientists, think about how you treat people who don't fit in. And then imagine them being smarter than you.
Yeah.
And what they're going to do to get even. Like, I don't know, I'm not going to say what, but
You text me.
it sure looks like they're taking their revenge right now.
No.
Okay, so,
This is
first
one.
problem, let's just talk about it, right? First problem is define physical property and chemical property, identify each type of property. So, physical properties are what? Things that don't involve breaking a chemical bond. And like boiling point, change of phase. Chemical properties involve breaking of bonds. So, yellow-green chlorine gas attacks silvery sodium metal to form white crystals of sodium chloride. Chemical, very good, right? Bonds are being formed and broken all over the place. A magnet separates a mixture of black iron shavings and white sand. Physical, right? You're not changing any bonds, you're just doing a separation. You're using the states that exist and the properties of the materials. You're not changing any of the property of the materials. 1.6. Which of the following is a chemical change? Explain the reasoning. Boiling canned soup.
Could be, but okay.
No.
Okay, explain the reason.
You're not changing any properties, you're just heating it up.
Right. You're changing the temperature, the motion of the molecules. You are not breaking bonds. Dom.
If you're boiling it, could you technically convert some of the liquid into gas or vapor or steam?
Yes, but what is that?
That would still be physical. Okay.
Does it depend on what you're boiling too? Like soup versus, I don't know, crystal meth?
No.
Okay.
No, it does not. Unless you boil it hot enough to break the crystal meth bonds.
Okay.
And we're going to say we're not boiling the soup. Soup is meant to be boiled. So we're putting some soup into vapor. We're not melting the noodles and turning them into something else. Although, if you heat it long enough, you can cause chemical reactions within your soup. But that's not what we're
But
talking about.
that's, yeah.
I mean, you could argue that, and I'd give you points for it, right? Well, I boiled it till it was empty, and the noodles turned black, and the chicken was, you know,
Charcoal.
was blackened chicken, and it was
That does sound
dish fit for New Orleans. All right, so toasting a slice of bread.
Yeah.
I like yeah. Why?
Physical.
Uh-oh.
Because you're changing the properties of the bread.
We're slowly
Right, because
carbonizing it.
something. What happens to the outside?
I guess crispy. It's gonna be fun.
Well, right, but it's not just a change of state, right?
Oh. So it is.
So the
chemical?
heat is doing something to the outside of the bread. It's causing some kind of change.
Burn.
Right. What's burning known as? Yeah, but what do we call burn when we burn something? Oxidation. So I would say yes, but I would also accept that. Well, it's still bread, right?
Yeah, bread is bread.
Yeah.
It's now just got a difference on the surface, but it's that difference on the surface that's different than just warming up soup.
Gotcha.
Okay. The difference between, we still have one more. Chopping a log,
No.
Physical.
physical, yes. Why?
You're not changing or breaking bonds, you're just cutting it in half.
Yeah, you're just changing the shape.
It's burning a lot.
Burning a log,
That's chemical.
chemical, right, because you're oxidizing it by burning, okay? Anybody have trouble with those? Anybody need further clarification? What if I said burning your book?
Chemical.
Chemical. What if I said reading your book?
Physical.
Okay, I'm a funny guy. Describe the difference between, I said it on camera too, I'm a funny guy. Describe the difference between extensive and intensive properties.
Can't
Which of the,
tell
fo-
you.
which of the, now we got to the part where I don't understand, right? And I confuse the hell out of you. So that's why I wanted to do these. The difference between extensive and intensive properties, and excuse my swearing on camera. Oh my God. Which of the following are intensive and extensive? So intensive are the ones that don't matter what the amount is, right? And then extensive, no, did we get that right?
Okay, so a boiling point would be intensive, because it doesn't matter what how much.
Is
of
that
it
the correct definition?
you're still-
Which one is extensive and which one's intensive? Did you take notes?
Extensive doesn't matter?
Intensive does not, the volume does not matter for intensive. Extensive, the volume matters.
Okay, so boiling point would be intensive.
Right, so one is a ratio. Which one is the ratio?
The density.
Density is the ratio, but it's like, is that an intensive or extensive property?
Yeah, intensive?
If intensive is the one that has ratios, yes. Okay, and then that's clear as mud. Which of the following are intensive? So,
Boiling point and density.
correct. The other two are thereby extensive.
Extensive.
And do we verify that with our notes that intensive is one and extensive is the other?
I mean, statistically, if
Because
there's
we,
only two.
I mean, this is not me, I can be confused about this, because I'm gonna be able to grade it. That's not the chemical definition, sorry.
Math.
Oh, this one made my head hurt.
Yeah, a lot of math.
I didn't like this one.
Intensive properties do not depend on the amount, so boiling point and density are intensive properties. Okay, good. Should be clear now. Although looking at the video, I'm sure we'll be open for debate, but we got it for sure. So, a small hole in the wing of space shuttle requires 27.7 centimeter patch, squared centimeter patch. What is the patch's area in square kilometers? Okay, so 20.7
So,
question mark kilometers. Okay, so this is interesting because we're going to want to take out the centimeters squared. So we want to get rid of centimeters squared. So 1 centimeter, 100 centimeters is 1 meter squared. 1 kilometer is 1,000 meters squared. And there you go. Questions? Why did I square it?
Because the answer is squared.
Right. So you cannot just say 1 meter is 100 centimeters because we have length times width. We have a centimeter here and a centimeter here. We have to convert both of them, right? So we have to square our ratio. in order to do the conversion. Do you see the conversion? Right? So we want to get rid of centimeters, so we put centimeters on the bottom and convert to meters. So we take off the prefix, convert to the base unit, then go back to the kilometers. Now there are a lot of tricks that people use to just do that in their heads. But I like to just make sure, because then I don't have any guesswork. If the patching material costs $3.25 per inch, what is the cost of the patch? So now we got to do the same thing. Was that right? 325? Yeah, per inch squared. So we have to convert to what unit are we in? Centimeters squared. So 1 inch, we want to get rid of inches. Inches go on the bottom. 1 inch, 2.54 cms squared, because it's inches squared. So now we got inches squared cancel, and that's the cost per centimeter, right? This is really, so really, let's do it, let's show it properly, right? So I don't confuse anybody. Too late. Times, what is it? 2.54 centimeters. Oh, let's do it the other way. Inch, 1 inch, 2.54 cms, and now squared, and now we get 325 per 2.54 centimeters squared. All right, and now we can just multiply by 20.7 centimeters squared, and we're left with a dollar amount. You guys with me? Is it too fast? Normally? Let's talk, should I talk through it slow again? You want to see it again, or are you guys good?
No, I'm good. I'll watch the video.
How many would like to see it again? Or have me talk through it again? No?
What's above the 2.54 centimeters? Is it 1 inch?
Yeah, that doesn't look like 1 inch, right? This is another place I fall down. You should see some of the writing of these people. They are really artists. They don't really know this stuff. Anyway, next, 1.36. The volume of a certain bacterial cell is micrometers. What's its volume in cubic millimeters? So we're going from micro to millimeter. And I think it's like, this is the kind of problems you're going to have to be able to do, right? And I'm doing them for you because I want you to get an idea of how fast they can be done if you do them often enough, and also to get an example of them. So 2.56 micrometers, cubic millimeters. Oh, I already forgot. 2.56 micrometers.
Yep.
Wow. Cubed, and I want millimeters cubed. So micrometers are 10 to the minus 6th meters, and then millimeters are 10 to the minus 3rd. So what we're going to do is we're going to take 2.56 micrometers, and I'm going to get rid of the micro conversion, and I'm going to say 1 meter is 10 to the 6th micrometers, or micrometers, or microns, all same thing. And now I'm going to convert, this is cubed, so this has to be cubed, right? Am I right there? Yes. And then we have to convert 1 meter to 10 to the 3rd millimeters, because it takes a whole bunch of little ones to make one big one, and then cube that. And that's, now we're in millimeters cubed. right? Because we got 3 different units, so we have to do the conversion 3 different times. Where else are we? Okay, perform the following conversions. That's just plugging into the formulas. You can find those. I'm not going to do those. And C is in the notes. 142C is in the notes because you can use the formulas to determine that. Okay, distance between 2 adjacent peaks on a wave is called the wavelength. So that's good to know moving forward. 247 nanometers, 145. So it's another conversion of units. Now, there are, I don't think I handed one out for this class, but there are conversion sheets that do that, and you will be able to use a conversion sheet with all these prefixes on them. So, but in the meantime, you get one of those. They're everywhere, available everywhere. And what are we doing? 247 nanometers. And the nano prefix is 10 to the minus 9. And we want to convert to meters. Oh, easy one. So nanometers, question mark, equals meters. And we're going to go, we want to get rid of nanometers, so nanometers go on the bottom. And it's a small number, so we need a whole bunch of them to make 1. So that also tells us that it's going to be a lot less meters than it is nanometers. So we get rid of the prefix, convert to the prefix we want, blah, blah. Yay. Okay. A beam of red light is 6760 picometers. And let's look up picometers somewhere and tell me how many that is. Wasn't fast enough. And what's the wavelength of angstroms? Oh. Angstroms is a funny one. It's 10 to the minus 10, I believe. Is that correct?
I don't have that on my chart.
I don't have it in my brain right now.
Yeah, angstrom, yeah, it's 10.
Angstroms is 10?
Mm-hmm.
I did have it in my brain. Yeah, how about that? Okay, so I'm going to get rid of picometers. 1 meter goes on top then, because I'm converting to meters. Then I'm going to add angstroms, right? So 1 meter is going to be a lot of angstroms. And, right? So I don't even really look at anything, do I? I take the prefix, I convert to the base unit, I add the prefix back on. Every single time the same way, right? I start with my unit and its prefix. To get rid of the prefix, I put the unit on the bottom. And then I put the base unit on top. Then to go from the base unit to the added prefix, I put that on top and put the base unit on the bottom to cancel. Sometimes people learn with this method, it's the same thing. Okay. I just do this other one. I like it, it makes more sense to me. But they are the same thing. Okay. Any question on that one? Okay, round off each number. This is a good one. Two significant figures. Has anybody got A?
Yeah, 3.5 times 10 to the negative 4.
1, 2, 3 zeros. Yes. So let's do it backwards. So we walk it. Where did I get a 9? So people lose points. 0, 0, 0, 3. Is that, did I leave off some stuff? Oh, 5, 5, 4. Right, just stay calm. What did I do there that you don't do?
You erased it. You were supposed to draw a line through it.
Well, there's that, but what did I do that you don't do? I checked after I finished, right? The key step to getting things right is to check after you finish. So I said 3, 5, 4, and I was like, oh, yeah, that's not right. And then I changed it to make it right. I compared my start with my end every time. Is it reasonable? That's a good question every time you do. Like, that's where you want to get. It's not really solving the problem. It's, did my answer be reasonable? And that's a higher level thought than I just did the problem. So that's where you want to get. And you want to get that way in all your work, right? Whenever you're doing something that you get paid for, moving forward, you're going to want to be able to go back and say, yeah, I dotted the I's across the T's. Okay. How about B? To 4 significant figures. Oh,
Question?
hold on, I didn't round.
Yeah, round that.
Okay, there are all kinds of things going around. As long as you're consistent, I still don't care. So 3.5 is fine, and 3.6 is fine with me, as long as you do it consistently. There are all kinds of little nuanced variations, like if this number is 5 or less, then I always go down. But if the number after the 5 is even, then I don't go for that. If I personally go down at 5, and then I go up at 6. But consistently, even just within the problem, right? So if you say, the first time I see 3.5, I go up, the next time we go down. That's all. Right, so that's 2. I'm not gonna give you a whole bunch of significant figures. Are one of those things where if it matters to your boss, he's going to tell you what to use, how they do it in that lab. So 35.8348. 35.8348. Check. Is that right?
Yep.
Whoa, it is. Now to 4. So that means I go 1, 2, 3. Here's 4. And now I'm going to decide whether I round up or down. That's less than 5. Easy decision. Always going to do it the same way here. And that's my number. And I don't even like this problem because it doesn't have units and numbers don't exist by themselves, but that's okay. 144. 0, 0, 0. How do we do that? Well, these zeros don't count as significant, right? And we only need 2 places, so we draw a line here. This is our deciding, it's no good. So we either write 14, 1, 2, 3, 4 zeros, or 1.4 times 10. 1, 2, 3, 4. 5. Yeah? Okay. And we're almost done with the homework. Let's see. Carry out the following calculations. Make sure it has the same number of significant figures. So what's the number of significant figures we're going to report in A? The first number has 4, the second number has 3, and the one we're dividing by has 3. So in multiplication and division, the smallest number is the dividing number. So we're going to report 3 significant figures when we do this math problem. We carry all the figures to the very end of the calculation, and then we do the striping or the stripping of figures, right? We do the Is that any question on that?
I'm just bad at math.
Okay, we're not allowed to say that. It doesn't matter whether you're good or bad at it, you do the best you can, and you don't say I'm bad at math. Got me? Yeah. Because that gets in the way of doing the math. You just do the math, right or wrong, doesn't matter. It's not one of those values. I'm where I am in math, and I'm gonna do this problem to the best of my ability, period, and move forward, okay? No programming yourself not to be good. It doesn't matter whether you're good, you're just what we're doing. I'm not good at this, but you don't hear me saying that. Oh, wait.
Oh, wait.
So, hi, camera. Anyway, okay, let's look at the number 2b. So addition has different rules, right? Multiplication and division, the smallest number of significant figures is reported. In addition and subtraction, we do it a little bit differently. So 1.110. Of course, this one's complicated. CM, 17.3. CM.
108.2.
Thank you. 108.2.
And then 316.
Just 316?
Yep.
All right. So, with addition subtraction, it's based on the decimal point, and the front numbers don't count. So we're going to do this addition, and that's 6, 1, 0, 14, 21, 22, 2, 3, 4, and then 4, right? Did that match anybody's number?
Yes.
Okay, so we have 442.610. But we don't report all that because, there's nothing on the other side of the decimal. Right? Because this is the smallest number on the side of the decimal, so only the numbers in front of the decimal count. And that's our answer.
That's only with addition and subtraction?
Correct.
Oh.
But if you now add multiplication, how many significant figures do you have?
3.
3.
Wait, so you don't round? Or you do round?
Ooh. Caught me.
You did it again.
Well, that's good. Round with this number, right? That's why I drew that line there, and I forgot to do it. Good call. Nice having you in class. Be sure to register. It's on tape. Okay, I freed myself. She edited it out. You're all right. Okay. The last one, right? Now we have a multiplication problem, and here's one of the things that we also need to know, which will be in the next lecture. But pi is a never-ending number. We can have as many digits of pi as we want, so that's not going to restrict. It's almost like what we call an exact number. And in my classes, exact numbers are any ratio that we don't calculate. So density is an exact number, anything like that. And so here our limiting factor is going to be the radius value, which would be 1, 2, 3, 4, 5 significant figures. Yeah, Don.
So when calculating sig figs, you do not take pi into equation.
Right. Pi does not count because you can have as many significant figures as pi as you have time to calculate.
Now, if it states just as it is 3.14 and doesn't use the pi symbol, would you then?
Right.
Okay.
Yeah.
Got it.
Right. As long as it's pi symbol, now we're talking exact number. If we are just giving a number, now we're estimating pi, right?
Yeah.
Okay. And I estimate I could eat 2 pi. All right, so we still have a few left, and where are we time-wise? Okay, we're still good. We have plenty of time to do our work. Write the following numbers in standard notation. Okay, so now we're going to go from scientific numbers to decimal numbers. So 555 times 10 to the 3. no decimal, right? There is?
5.55.
So 3 times, so that means it's bigger than 0, right? So we're gonna go the positive way. So we dance it, 1, 2, 3. So 5, 5, 5, 3. There we go. Do we need the decimal? No, we do not. We just have the holding place. If we put a decimal here, what happens?
Makes a 0 significant.
Makes a 0 significant, gives us 4 significant figures. We only started with 3, so we can't do that. I see some lost faces. Right? If you're having trouble with significant figures, there's a million videos on scientific notation to decimal conversion. I don't have them listed. So 1.0070. How many of those numbers are significant? How many sig figs do we have there?
5.
Yes. Right? The final 0 counts. Why does it count?
After the decimal.
Yeah, it's after the decimal. Right? So a decimal says anything after it counts. So when we change over, 1, 2, 3, 4, 5, 6. And we need a decimal, right? 1, 2, 1, 2, 3, 4, 5. How do we do it? Oh, we don't need a decimal, right? No, we do. Right? Because we have to report this 0. How do we do that?
Put a .0? No?
Well, if I put a point here, now I'm counting, still not counting this one, right? If I put a point here, I'm not giving you the right number.
Put a 0 after the decimal.
Well, now I'm giving you too many, right? Right now, all of these count. So it's kind of, ambiguous. You can't really report it that way, can you? Anyone? Anyone can help me on that?
Don't some people put a line under the numbers to report sig figs like that?
Well, I don't know, but that'd be one way to get around it, wouldn't it?
Would you take that on the test?
I would say this is ambiguous on the test. I don't know a way to convert this and show, there's no universally accepted method of doing this, right? Because 1, 2, 3, 4, and there's 2 more, and there's no way to count this 0.
Yeah, would that be?
So what you're saying is, in some places, they do that.
I like it.
Kind of like how you did it up there.
Okay. All right.
Okay.
So that will not be on the test, right? Why? Because it's confusing as heck. It doesn't make any sense. It's arbitrary. Don't go for arbitrary. We're not here to be arbitrary. Get that in the later stages of your career. 8.85 times 10 to the minus 7. Really? I made these, so why don't I edit them? 8.87 times 10 to the minus 7. Is that right? Okay, so now this is less than 1, so we're going to move that way. 7.
It's 8.85 times 10 to the negative 7.
Thank you. And so 1, 2, 3, 4, 5, 6, 7. Is that right? 1, 2, 3, 4, 5, 6, 7. Yeah. Woohoo! And this does this have units? No. Again, no units. I'm gonna have to fix these problems. And the last one, 10 to the minus 3. And so this is also going to be less than 0, right? 3.00, 4. 10 to the minus 3. So again, our conversion is going to be minus 3, and it's going to be this way. So 1, 2, 3. 1, 2, 3. Right? Because you can always count it back if you're not sure. That's the check. Right? Go back to the number you started with. All right. And then let's look at the last two. Carry out the calculations. These are too hard. I'm going to leave them for you. But let's get the number of significant figures correct, right? So the first one is recognized as Planck's constant, or maybe it isn't. And then speed of light. So Planck's constant times the speed of light divided by nanometers, which is wavelength, turns out to be one of the equations that we like. But how many significant figures?
3.
3. Very good. 3 significant figures for A. B is, again, 6.626. And molecules per mole. Boy, that's not even a right number there. Because what do we use for molecules per mole? Avogadro's number, which is 6.23 times 10 to the 23rd. So something happened there. Times 1.3 times 10 to the 2 divided by 46.07. Again, 3 significant figures. The last one, which is actually has the right Avogadro's number, and then 2.18. And then we have 1/4 minus 1/9. So that's going to be the determining factor. And that's going to be, oh.
Yeah, so to figure that out, do we need to change these fractions into decimals and count those figures? Okay,
Correct.
and then whatever the smallest of those.
Right, so they're still going to determine, right there. Go ahead.
Are they, is 1/9 an exact number though? It doesn't have to be an exact number.
Ooh, that's a good question. Right?
Say it again?
Say it again.
Because it doesn't have an unit attached to it, it looks like it's an exact number, and then you would count it when counting significant figures.
Yeah, because whole numbers are what? It's not a counting number. Boy, you could get away with that argument. I would have to, again, it's too vague for me to put it in and to use in a test situation. But theoretically, it's a good discussion question. So if you were to hold it to 3 significant figures, I'd be fine. If you converted it to 3 decimal figures and did the subtraction, I'd also be fine.
Wait, so you're just wanting to write down how many sig figs are in the thing?
Or do you want us to do all?
No, I wanted you to carry out the calculation. I just said we've been burning up enough time. And then let's look at the last 2. This problem is also a mind problem, and for you to try to figure out. It takes a long time, and I'm not going to discuss that problem. But if you want to discuss that problem during class or outside of class, I'd be glad to do it. What I would tell you is the answer in the study guide is not necessarily correct. Liquid nitrogen is obtained from a liquefied air and is used to industrially prepare frozen foods. It boils, okay, at 77.36 K. Convert that to C, minus 273.16, 273.15, excuse me. And then what is its temperature in Fahrenheit? You gotta look that one up. The boiling point of the density, the boiling point, at the boiling point, the density of the liquid is 809 grams per liter, and that of the gas is 4.566. How many liters of liquid nitrogen are produced when 895 liters of nitrogen gas is liquefied at 77.36?
Oh, that hurt my head.
Right, so there's some conversions involved now, and that also is going to take some time, and I want you to think about it, and I'm not doing it. Okay, so let's get to lab. You have your pre-labs done? Yeah? Okay, I'll walk around, sign it, and then you can get started on lab. Thank you for so much attention. I know that was a little bit more than we're used to. So. But basically, we've got 10 points out of that homework without even doing it ourselves.
Here.
No, we're not doing that again. Because I can't afford to lose a pen for you every time they show up. Beautiful, beautiful, nice correction.
Oh, that's right here, sorry.
Okay. Oh, I like this too. Okay.
So when you want us to submit the pre-lab assignment, do you want us to just submit the like math one
Yeah.
or all of,
Well, I'd like to see what you did before you got here.
right,
Yeah. And then the rest of it is after you got here.
like the procedures and all that?
Yeah, yeah, because that's part of what we have to do to prepare. So the pre-lab is what you have to do to prepare for class.
Yeah. Yeah.
And you can do it separate, it's okay.
I can just submit it either way. Okay.
Whatever, like, I'm not, just, if you do it, I'm gonna
I
give
did
you
what,
credit.
3 times?
I submitted the pre-lab assignment.
And as we move